All right, here we are in geometry at 3.2, and the section is constructing perpendicular bisectors. So remember that a bisector is something that cuts something in half so that each side is the same length measure, and perpendicular means it meets at 90-degree angles. So this is pretty straightforward. You're going to open your compass, put the pointy part on one of your vertices or one of the endpoints, and you want your compass open more than halfway. It doesn't really need to, it could be the whole length of it. It doesn't have to be though, it has to be more than halfway. And once you do that, from each point, from each endpoint, you're going to swing an arc above and below your line segment from each endpoint. All right, so you have these intersecting arcs above and the intersecting arcs below the line segment. And then you're just going to take your straight edge and you're going to connect that intersection with this one. And if you do it right, it's going to be a perpendicular, and it's going to bisect that segment. All right, and this leads us to the fifth conjecture, and it's the perpendicular bisector conjecture. It says if a point is on the perpendicular bisector anywhere along here of a segment, it is equidistant from the endpoints. So let's just see what this. If I have a point there, that means that distance and that distance, pretend I actually drew those with a straight edge, those are going to be the same. Doesn't matter where the point is. If I have a point here, this distance and that distance are going to be the same. Okay? And remember when we talked about converse of statements? This is an if-then statement. There's the if. There's a then right here. The converse of this statement would be if you just switch these two parts around. It would say, if a point is equidistant from the endpoints, then the point is on the perpendicular bisector. So C5 and C6 are converse statements of each other, and the converse in this case is true. All right, let's look at number 6 on this worksheet. And it says construct a right triangle. Okay, well, we're going to do that first. Before I read anything else, I'm just going to go ahead and construct a right triangle. Okay, there's going to be my base. And let's just make a couple of endpoints here to work off of. So my opening needs to be more than halfway, and it is. I'm going to construct a 90-degree angle, swing an arc above and below the line. Do the same thing here. Connect those intersections. Here's another tip for you. First of all, if you're doing geometric constructions, you want to make sure you have a really sharp pencil. Always have a sharp pencil. And when you want to connect this to this, put your pencil up there first and then stick your straight edge on it. You're liable to get more of an exact location. Notice how my pencil mark is directly at that intersection. It's not off by a little bit. And you're going to be able to tell if it's off a little bit because it won't look like a right angle. Okay, so there is a right angle. And let's just make my triangle right there. Okay, and it says with right angle B. So this is B, this will be A, and this is C. Okay, now it says to construct a median. Well, what's a median? Okay, so a median, oops, that's not how you spell it. Try that again. A median connects a vertex of a triangle to the midpoint of the opposite side. Okay, it says to construct median BD. That means I'm going from this vertex to the opposite side where the middle is, all right? Well, if I turn my paper around and let's just look at this side, I want to find the middle, right? Well, can I just find the perpendicular bisector and it will hit the middle? The answer to that is yes. Okay, open your compass to more than halfway. Swing an arc above and below the line that you're trying to cut in half from each endpoint of that side. I need to connect this and this. And I don't really need to draw the whole thing. I don't need to draw this whole line because I really just want to know where the middle of that side is so that this is equal to this. All right. And now if I want the median, remember I'm looking for the median. I just need to connect, oh wait, let's label that D because that's the middle of the other side. And I need to draw that. I'm going to do that with a different color. So that's the median BD. And now it says they want you to compare BD and AD and CD. Usually when it says compare, they want to know how long it is, or what the measurement is. But we're not going to use a ruler. I'm going to compare those lengths with my compass. So BD is that long. Oh, look. AD is the same, and CD is the same. Okay, so then it says, what do you notice? Well, don't we notice that these are all congruent? So apparently, if you construct the median in a right triangle from the right angle to the opposite side, that median will be the same length as the two halves of the opposite side. Also, since this whole chapter is on constructions and your quizzes and a test, anything I ask you to do for me for an assessment is going to be really testing if you know how to do these constructions. The only way that I know you're doing it correctly is if you leave all these compass marks. Don't erase them because you think they don't look very neat and tidy. It's the only thing I have to tell me that you're doing it correctly. So leave the compass marks. And that's it for 3.2.